Question 14. A ship leaves Port P and travels 150 nautical miles to Port Q on a bearing of 110. So there's Port P, put a north sign, and we go 110 degrees, which is going to be 20 degrees beyond the 90 degree mark, to Port Q. Once you draw your diagram, you're going to have to put that distance in on the bearing of 110. It then travels 120 nautical miles to Port R. So you now need to take direction again, put a new north sign, and go 200, it goes 120 nautical miles to point R on a bearing of 200. So you've got to go beyond 180, so another 20 degrees beyond 180, and that bearing there is 200. So R is down there, and then they want you to explain why that angle there is 90. All the information, we've got 150 nautical miles and 120 nautical miles. This must be angle Q here. Okay, so explain why angle PQR is 90 degrees. Okay, so what do you want to do, girls? What's this one here? I'd call this angle, you can call it N, I suppose, NQP. You can call that N1 and N2, North 1 and North 2. So angle N2QP is what? What's this angle in here? Come on. Co-interior. I know you like doing alternate, but you need to look at co-interior. When you've got two north signs facing the same way, no, what's this? Yeah. Angle N2, north sub 2 QP is 180 minus 110 degrees, which is 70 degrees. Reason? It co-interior angles. Parallel lines. So you've got co-interior angles, so that in there is 70. What would you use next? Look, there is a few different ways you can do it. I'm showing you one way. We can do another way in a minute. What else have you got? Oh, well, if that's 70 and that's 200, what could you use? Angle sum at a point. Angle PQR is 360 minus 70 minus 200. Which is is it 90 degrees? Reason? Angle sum at a point. Now, there is another way. Okay, that's one way to do it. I'll just get rid of this, find the bearing. We'll do that in a minute. So the last bit was find the bearing of P from R, isn't it? Or R from P. Whatever it was. So that's 90 degrees. We know that's 90 degrees. How else could we have done that? Did anyone do it another way? So you can do alternate. To do the other one, you could have, or the other way we could have done this. So that's one way to do it. One way to do it was go co-interior, that's 70, then angle sum at a point, that's 90. The other way is to put a little, you'd have to put a little dotted line there and a little some east-west lines. Okay? This is the other way, and you could have gone 20 in here. You okay with that? Alternate 20. And then you'd have to do that this is 70. But I think I like the first method. It's not as messy. All right, so definitely the first method. And now the other bit is to find the bearing of R from P. I think it was R from P. How are we going to do that? The reason we showed that this is 90 degrees is now we can find any angle in the triangle using trigonometry. So if they want the bearing of R from P, it'd be a good idea to find this one. Because we know the bearing is going to be 110 plus whatever this is. So put your theta there. So when they say show that this is 90 degrees, explain why it's 90 degrees, you can use trigonometry. You can use either Pythagoras' theorem, will give you the distance PR, or you can use trigonometry in a right angle triangle. So let's go. What are you going to do from theta? Sine, cos, or tan? What's that? What's that? Go. Tan theta is opposite over adjacent. Tan theta is 120 on 150. So theta is 10 to the minus 1 of that. 38 degrees, 39 minutes. But we're going to go, so 38 degrees, 39 minutes, which is 39 degrees to the nearest degree. And so the bearing is... bearing of R from P is, and if you look back at your diagram, it's going to be the 110 plus whatever you just got. 110 plus 39 equals 149 degrees. Okay?